Hi guys, how you going? I'm going to look at some different types of functions today. A couple of interesting functions that we already know about. So a lot of this will be review of what we already do know. So we're going to start with the first and the most basic type of function, which is a linear function. And so here's an example. So in this topic we're going to be looking at some examples of where that really works. So this might be the cost of driving a certain distance, depending on probably a taxi situation. So, you know, it costs $3.30. You can see if you don't drive anywhere, just hop in the car, $3.30 flag fare, and then it's costing obviously $1.75 every time you go a certain distance. So if you look at the graph itself, okay, so that's our initial bit, which would be our flag fare. And then you've got the slope of our line. Okay, to work out the slope of the line, it's simply rise over run. And so therefore, this is the equation that we've got over here. So CD is equal to 1.75D plus 3.3. So the idea of this is if I knew the distance that I need to travel, I could work out the cost of my trip. Okay, so that's the idea of using my straight line distance formula. Okay, so we always know that this particular function is in the form of y is equal to mx plus c. So that is my slope, and this thing over here is always my y-intercept. Okay, so we've already done some work with that this year. I can't seem to write. So hopefully that will help you in terms of understanding. Now, all of these particular types of functions have how many turning points? Okay, they have 0 turning points. Alright, so that's what we know about all these particular types of functions, that they don't have any turning points at all. Alright, so linear function, alright, it's got a power of 1, okay, doesn't have any turning points. Now, quadratic functions, okay, they're in the form of ax squared plus bx plus c, okay. Now these functions here, right, have one turning point. Alright, so they have one turning point in terms of this thing over here. In regards to the quadratic function, we did a fair bit of work on that last term. Okay, we've got our local vertex point over here. Okay, and we have our axis of symmetry as well. So these are the things that you need to be able to identify, because we either have the case of a local minimum or a local maximum. So that's what we'll be looking at in this particular case over here for these. Okay, remember that vertex point, there were a couple of ways you could do that. You could either use x equals the minus b over 2a, or you could have used the equation, so then obviously the other point was going to be equal to minus b over 2a, and then that was the function by putting it into your function, minus b over 2a. Or the other way of looking at that was to look at your y is equal to some value a x take h squared plus k, and remembering our vertice point there was h k. Alright, so you might want to do a little bit of revision of what we did last term in regards to that concept. Now, the next type of functions that we're looking at are called polynomial functions, and all of these things here are what we classify as polynomial functions. Alright, so they are in the form of ax plus b, okay, y is equal to ax squared plus bx plus c, okay, y is equal to ax cubed plus bx squared plus cx plus d, okay, y is equal to ax cubed, x to the 4 plus bx cubed plus cx squared plus dx plus e. Now, keeping in mind all of these things here, you don't actually have to have any more than maybe just something like x to the power of 4, because the values of b, c and d could all be 0. So this accounts for any function that we would have with a power, and they're all polynomial functions. Now, the main thing here is this has got how many turning points? 1 turning point, okay, actually 0 turning points. This has got 1 turning point. This one here will have 2 turning points. and this one here will have 3 turning points. You get the idea. So you've had something like y to the 100, y(ax) to the 100, then we would know that that would have, technically, it'd have 100 take 1, which would be 99 turning points. Now, these sort of functions, okay, they might look something like this, okay? So they might go something like that. So this one here, because it's got 2 turning points, we know that is a cubic, okay? So that would be that type of function here, all right? So we'll be looking at those type of functions in a bit of detail, but as we're doing a bit of a review of all the types of functions that you need to do, I won't do any more on this. I'll do a video specifically on those types of functions. Alright, so the next one that we want to look at is the exponential. And now in your first investigation you've been looking at these types of functions, haven't you? So they were y is in the form of a times by b to the power of x, and keeping in mind our value in our calculator, quite often that's giving you in the form of a times by x to the power of that. Alright, so obviously some value n there, so what we could say is our b value is equal to certainly e to the power of n. Alright, so that's the idea of these functions. Alright, we know these sort of functions are growth and decay functions. Alright, so they have that curve, so we've done a fair bit of work with them, so I'm thinking you should really have an idea about those. Looking at the power model, okay, so if you start looking at a power function, alright, and that's another option on your calculator. So these are in the form of y is equal to a times by x to the power of b, okay, where a and b are constant values. And again, they are growth type functions, okay, so that's technically what they do. Obviously, if x is equal to 0, y is equal to 0. Alright, so all of these functions here always go either, they could go like that, or they could go like that. They always go through 0. Alright, so those sort of functions there. Now, we'll do a whole section on these ones here this year. These are called rational functions. Okay, so all these rational functions are functions which have a function on the top divided by a function on the bottom line. Alright, so an example of something like that might be y is equal to 2x, alright, all over something like x squared plus 1. Alright, so if you had a function like that, I don't know exactly what this looks like, but these are the sort of functions that have these asymptote lines. So I might have an asymptote line there and an asymptote line there. Okay, doesn't have to look like that, but it could be one that goes sort of like this sort of shape. Okay, now they look a little bit scary, but you don't need to worry too much about these because we have our calculator. Technically, all we have to do this year and next year is to graph these on our calculator and be able to sketch them. Alright, so not that hard, but I will do a video just specifically on the rational function, so you have a bit of a guide there with those. Now, the key thing is, all a function is it's a way of representing one function, one variable against another variable. Okay, so in our last investigation, we were looking at modelling exponential functions to look at verifying this particular formula here, and you know, that was, you know, hopefully helping you in terms of understanding that particular formula, what the A and B do. But we technically could do that for any function. So when you start looking at these polynomials, they open up a lot of different examples where, you know, things can vary with respect to the other variable. So shouldn't be too worried about them. You know, we will work systematically through these types of functions. So we're going to start from our linear functions, we're going to get onto our quadratics, look at some polynomials, and then we'll spend some time looking at some rational functions. Alright, so good luck with those, and hope you have success with them. If you need some help in class, make sure you ask for some help. Thank you. See ya.